calculate for the bit. Louis and Ernest, you have to exhaust your bits from the left. So if you want to be able to use up some of the bits in the last octet, then you must make sure that the first three have all been exhausted. Okay, somebody said we're good. That's good. Great. So these are the two scenarios you can have, but this, you can have this. Okay, simply because we exhaust the bits from the leftmost. It's like pouring water in a bucket or in a pot, and then you have 4 parts. So 1, 2, 3, 4 parts. You fill the first 2 parts. You don't fill the third one, and then you start fetching water in the last one. It doesn't make sense, right? You expect to fill out the third one as well before you move on to the that's an IP address. What you have here is an IP address. It's not a subnet mask. There are 2 different things. There's IP addresses, and then there's subnet mask. What you gave me here is a subnet mask. But what you have now, you have posted by Ernest, is such an IP address, which has got a 192.168.1.1/24. Yeah, this is an IP address. This is a subnet mask. So we absorb the subnet mask from the leftmost bits, before we get to the final one. But with IP address, you don't have to worry about that part. That you can switch any how you want because they are IP addresses. I hope that clarifies your scenario here. Okay, so every time you see a subnet mask, they're going to be within this range. You're going to see a 255.255 or something, depending on the class of IP addresses you're dealing with. This is a class C IP address because it starts with 192. So if you go to the slide, you notice that a class C IP address starts with 192 and happens to be a private IP address as well. Private IP addresses are non-routable. Whenever you see a 192, it's an easy guess that it's a non-routable class C private IP address. Okay, so moving on. So now let's go back to the slide. So now we can from this we can identify our subnet IDs as well as our node IDs. Okay, so that's like the 2 scenarios that you can be able to compute the network IDs and then the node IDs. In some scenario, I'll give you the subnet mask. From there, you can easily tell if you understand what the class, if you know which class it belongs to, then you can easily tell what would be your subnet mask after you break it down into its binaries. And then from there, you can spot where the nodes bit or the node IDs are going to be, or the number of node bits are going to be reserved. Or in a different scenario, I'll just give you the node ID and tell you which class of IP address you have and ask you to calculate the subnet ID. And that's also easy. If I told you the class, it should be easy to figure out given the node ID, the number of bits within the node ID. So for instance, if I tell you it's a class A, okay, let's go to this scenario real quick. I give you a class A IP address, a class A subnet mask. Let me go back to the drawing board. Oh. I give you a class A subnet mask, okay? So I'm going to give you a 255.128.0.0. And I tell you it's a class A subnet mask. And I tell you that with this, you have a node ID with, so let me see, let me see if I can go through this. Okay, so I have 1, 2, that's 15 bits. Calculate your subnet ID. So calculate subnet ID bits. Who give me the answer to this one? What will be the answer to this one, guys? Type it, or calculate it yourself. Open your notebooks, do the calculation, and see if you can figure it out. So what will be the subnet ID bits, or the total number of subnet ID bits? There's an easy way to calculate this, because it takes time to understand it. If you start thinking too hard on this, it means you have not really gotten the concept well packed yet, which is understandable. Just you need to go through the slides first. And then once you understand the slides, you can easily figure that one out. I'm getting 18 bits. That is too huge. That is wrong, by the way. I don't know how you got that, but that's completely off. Oh, sorry. I think I screwed a question. I should have told you that the node bit is wrong. Sorry. The node bit should have been 1 second. It's a 23, sorry. 23. It's not 15. It's 23. Yeah, so that was wrong. It was 23. Yeah, the node ID should be 23, not 15. With this scenario here, it should have been 23. So now what would be your subnet ID bits, the no subnet ID bits? Somebody's saying 9, that's wrong. Anybody else? I'm getting 8, 9, 6. No, those are all completely off. The node ID 16 is wrong. The node ID has got 23 bits. Somebody said 23. That's wrong. You guys are going completely off. Okay, so now let me help you guys out, because the numbers I'm getting is too much. It's completely off. So it's a simple scenario. It's a simple concept. Remember, it says it's a class. No, that's the wrong. It says a class A subnet mask. So technically, your full node bits should have been 24 in total, 24 bits in total. But it said it has 23. So it means it's only 1 bit that's left. And that will become your subnet ID bit. So it's 24 minus 23, which is 1. Yeah, 1 bit. Now you guys are getting it. Yeah, so this is something simple because it says class A. So instantly you click in your head. Class A has got 24 bits of node IDs, of node ID bits. So if this question is saying now the occupied, allowable, the assignable number of bits for the node ID is 23, it means only one has been what? Subnetted. So that one becomes your what? Your subnet ID bits, or bits in this scenario. There's only one. Are we good? Okay, now let's try with a class C, since you guys are now catching on to this. Let's try with a class C. So here's a class C1. So here's a class C1. We have 255.255.255. Instantly it tells you the class what? Class C. And then here I'm using, I'm going to use 224. So in this case, I'm going to tell you that you have, so the question for this one would be, you have subnet ID bits of, let me see if I can get this out of the way. So if I have, 1 second, okay, let me just get my calculation right before I put the number up there, so I don't confuse anybody. So you have, give me a second, okay, guys, give me a second. Come in and write it up, minus, okay, so you have a subnet bit, subnet ID bits of so you got of 3 bits. Calculate node ID bits. What would that be, guys? Five, there you go. Yeah, somebody catching on. So it's 8 minus 3, and that gives you 5. Correct. Who's that? Wisdom. Okay, and then what? Who's that then? Comfort. Okay, great. Is that a guy's name or a boy's name? Or a girl's name? I'm sorry. So that's 5. Great. So you guys are catching on. Okay, so you make sure you understand how you got that. Now in this scenario, I'm just giving you bits. So now let's try to find the actual number of IP addresses now. So now that you got 5 bits for the nodes, tell me the total number of node IP addresses now. Anybody guess on that? Using the formula, 2 raised to the power n. This I'm asking for is a total, there's no minus 2. If I were to say, give me the assignable, there you go. 32 now, there you go. So now you actually have 32 IP addresses that can be assigned. Okay, so that's good. You guys are catching on very, very well. Now, tell me the total of IP addresses that can actually be assigned, assignable IP addresses. 30, yes. Somebody even answer the question before I finish my question. That's good, that's good. Yeah, so you guys are catching on. That's good, I like that. The guys that are getting lost, please don't get lost. It's just simple manipulation that we're doing. We're doing over here. We're just manipulating bits and zeros and ones over here. Okay. Now these are just the preliminary stages of IP subnetting. Now we're going to apply it to a real scenario here. Okay. So now let's try to apply that to a scenario. So let's go back to the slides, and then we actually use it to calculate for some few questions. Let me see if I can find some questions over here. So here's a situation where you have example 1 or example 2? Okay, this already has the solutions as well that you can go through. So you have, in this case, you've been assigned a Class C network number of 2, which is an IP address of 200.133.175.0. Now they've told you the Class C, so you know by default it's gonna have a 255.255.255.0 as its default subnet mask. So keep that in mind because the Class C. Now the first question is, how many subnet bits do you need? How many subnet bits do you need given this particular scenario over here? We have 2 IP address 200 blah 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 .0. So the question says, I think the question went back to this. This was supposed to be the questions. This was supposed to be the question itself. You assign a Class C network address of this. Utilize this network across multiple small groups within an organization using 14 subnets. Okay, I'll get to your question very soon, okay? So they say you have 14 subnets. That's what it's telling you. They're telling you to use this IP address with a Class C to address multiple small groups within an organization using 14 subnets. And the first question is, how many subnet bits do you need? So the first thing you do is you say 2 raised to, because they're asking for the number of subnet bits. And since they told you that it's 14 subnets, it means that you can easily find the bits because it's 2 raised to the n bits minus 2, which gives you the total subnets that you need. So it'll be 2 raised to the power x, which you're trying to find out, or 2 raised to the power n minus 2 equals 14. And when you do the calculation, you notice that 4, 2 raised to the power 4, which happens to be what? What is 2 raised to the power 4, by the way? 16, right? 16 minus 2 is 14. So technically, the bits that has been used for the subnet is 4. So 4 bits corresponds to what? The 14 subnets. That you're going to be needing to address your multiple small groups within an organization to set up your network across that small organization that you have. The second question is, how many nodes would you have on each subnet now? Now, keep in mind, it's a what? It's a Class C IP address, okay? And you're supposed to have by default 8 node bits. You're supposed to have for your node IDs and the number of bits. And then you're supposed to have, in terms of subnets, you're supposed to have 24 subnet bits because it's 32 minus 24, which is the 8. Okay? But here's a case that we have subnetted 14 IP addresses using 4 bits. Okay? So 14. So if it's 4 bits out of the 8, it's going to left what? 4 more because it's 4, which gives you the 8. It's 8, and we've subnetted 4 bits out of it. So there's 4 left, which will give you the what? The nodes. But the question is the number of nodes that will be used. So if it's 4 bits, then 2 raised to the power 4 should give you a total number of nodes, which in this case will be what? 16, right? Right, guys? Guys? Oh, sorry, you guys are not. Yeah, so it'll be 16, but minus 2 because these are, you have two unassignable ones. So it'll be 2 raised to the power 4 minus 2, and that will give you what? 14. Back to the same subnet that you have. Okay, so it's just 4, 4. We've only taken out of the 8 bits that we are supposed to have for the class C, we've subnetted 4 bits of it. So we only have 4 left. Okay, and that gives you the 14 nodes of IP addresses. The other question that you have is, what is the subnet mask? And now this is where the tricky part comes in. So this is where you're supposed to do the calculation. So to do that, let me go back to the drawing board so we can be able to find this, answer this question over here using this scenario. Okay, so coming back to this, the subnetting fun or what? I hope you guys are enjoying this. So we had 200 dots. Let me go back to the PDF again. See what I have. 133.175. 133.175. 133.175.0. And out of this, based on the question the scenario we have, we're supposed to have a default subnet mask of 255.255.255 because the class C.0. But we took 4 bits out of this 8. So this was supposed to be, this 0 here is actually 0 in binary 0, 0, 0, 0, 0, 0. One more 0, right? But we use 4 of it as what? Subnet. A subnet ID bits or subnet bits. And we only had, so we made it all ones basically. We made it all 1. Okay? And we had this 4 bits left for what? Our node. Our node bits or node ID bits. Whichever one you want to go with. Okay? So it means that the actual subnet mask should be 240, because if we have all these to be 111, it means this is 128 plus 30 plus 64 plus 32 plus 16, which gives us 240. Keep in mind, I told you, if the first 4 bits are all maxed out, it sums up to what? 240, because the last 4 is 15. So 15 plus 240 is 255. So technically, the subnet mask, the correct subnet mask for those 14 subnet that we have is actually 240. So this will be the correct subnet mask that we're going to be using now for this to basically represent this IP address when we want to calculate the broadcast domain. Yeah, I have a question over here. Let me see if I can go through that. Somebody's saying that, so please, question, what if a host has the IP address, blah, 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 /26? What are the network address, broadcast address, and valid host address for? Okay, that's a good question. But let me go to the same thing. So let's finish with this one first, then we come to your question. Okay? Who is this guy here? iPhone guy. Let's finish with this question here before we move on to yours. Okay? Are we good? Okay, so let's finish this one first. I think once we understand this, then we can apply the same concept to your question. Okay, so now we know the default subnet mask for this particular IP address actually It's no more 255.255.255.0 anymore, but actually it's 255.255.255.240 because we used up 4 bits of the 8 allocated for the nodes, giving us a subnet that we're going to be forming. That leads to the 240. Okay, great. So now, if you want to find the network address, then it's where you start doing the fancy calculation. You have to convert all of these to binary. It's the only way you can see how the bits-wise addition comes into play to give us the network address. Okay, so to calculate the network address, we have to basically do what you call a logic bitwise AND. So it's like in computers, we don't do addition. We do what you call logic AND. And you guys will take class like that. That will tell you what AND means. AND means that to basically add 2 binary numbers or 2 binary digits, and using AND, it means that they both have to be on. They both have to be 1 to get a 1. So for instance, if you have, let's say, you use 4 bits, 1 0 1 0, and then 1 1 1 0. If you were to logic AND this, bitwise logic AND this, it will be 1 1 is 1, 1 0 is 0, 1 1 is 1, 0 0 is 0. This is what the representation of AND means. So that's how you apply this to this concept, to this this IP address in subnet mask, in order to derive your network address. So let's go through it real quick. So 200 will be, since 200 is bigger than 128, it means the first 4 bits will be 1. The second bit will also be 1 because it's 128 plus 64, which gives you what? 190 what? 92, right? 128 plus 64, 192. So we need 8 more, right? So it means this will be a 0, this will be a 0, but the 8th bit will be 1, and the rest will be all zeros. So this is 200 because it's 128 plus 64, which is 192, plus 8, which is 200. Dot. Now what are 133? 133, since 128 is smaller than 133, it means the first bit will also be 1, but the second bit cannot be 1 because it's 64, which is bigger than the rest of the value. So you take 133 minus 128. What do you have? You have 2, which gives you 3 plus 3, which is 5. So you actually need 5 more. 5 additions. So the rest is going to be 0, 0, 0, and 0 here. But 4 will be 1, and 2 will be 0, but 1 will be 1. So you have 128 plus 4, which is what? 130 what? 130 what? Guys, 132, right? It's 128 plus 4 is 132, plus 1 is 133. Now, 175, obviously, the first bit 120 will be on. Since 64 is large, so you take 175 minus 128, what do you have? You're going to have a 0 here, obviously. So 128, sorry, you have 175 minus 128 gives you 47. So you need 47. How do we get 47? We can get 47 from 32, which is, so this is going to be off. 32 can give you that. Now 47 out of 47 minus 32